Significant figures indicate the number of digits in a measurement that are important and contain significant information. So the general rule of thumb is that the more significant figures that our measurement has, the better quality the measurement. So we establish the rule that the number of significant figures in a measurement are those that we can read off the scale. Those are those that we know with certainty, plus that one that we estimate that's not actually falling on the scale. So the number of significant figures in our measurement are all of those that we can be certain about, those that we can read off the scale, plus that one estimated one where we are going one digit smaller than the smallest increment on the scale. So how do we count up the number of significant figures in a measurement? We have a few simple rules. The first rule is that any non-zero number in a measurement will always be significant or important. So 15 has two non-zero numbers, therefore it has two significant figures. 3.11, three non-zero numbers, therefore three significant figures. 7928, four non-zero numbers, therefore four significant figures. Now, when we think about zeros, it starts getting a little bit more complicated. So, we have a couple of rules to do with this. We need to keep in mind that zeros in numbers can be in different places. Zeros in a number can be what we call leading zeros. These are zeros that occur at the front of a number, and they are not significant because we can increase or decrease the number of zeros in a measurement simply by changing the units that we use to make the measurement. So, for example, $0.01, which appears to have three numbers in it, is not any better than knowing that you have only 1 cent. Confined zeros, or sometimes I call them buried zeros, these are the zeros that appear in the middle of a number. Now, these guys are always important. You can't remove those and just eliminate them without significantly changing your number. So this number here, the leading zeros at the front are not significant. The two non-zero numbers are significant, and then these two zeros that are buried or confined, they're also significant. So this number in total has four significant figures. The next rule we have deals with how we cope with zeros that are at the end of a number. So all of these rules concerning, all of these examples here are where we have a number with zeros at the end. I call these trailing zeros. And the rule that we have is that trailing zeros are important if your number has a decimal point, or alternatively, if the trailing zeros are covered by what we call an overbar. So in this example here, we have one leading zero, that's not important. We have two non-zero numbers, they are important. And then we have two trailing zeros, which because they come after a decimal point, they are important. So this number here has four significant figures. In the example here, we have two trailing zeros and two non-zero numbers, but the trailing zeros are covered by an overbar, so therefore they're important, and this number has four significant figures. In the third example here, what we see is that we have two non-zero numbers, we have two trailing zeros, there's not a decimal point, there's no overbar, so those guys are not considered to be important, and our number has only two significant figures. So these two measurements here, the first two, they are of equal quality. They both have three significant figures, three that were measured off the scale directly, and one that was guessed at or estimated. And this guy at the bottom here, it's not as good a quality measurement. It only has two significant figures, one that we read off the scale, which will be the 2, and then the 5 there, we guess that that's 5. Alright. So here's our rules all kind of summarized on the one slide. Any non-zero number is significant. Zeros that appear in the middle of our number, called confined or buried zeros, they're always important. Leading zeros at the front of the number are never important. And trailing zeros are sometimes significant or important. And the rule we have to indicate that they're important, we will either cover them with an overbar or we'll write our number such that it contains a decimal point. So a few examples here. We're going to add up the number of significant figures in each of the following measurements, keeping in mind our rules. So what have we got? We've got 2 leading zeros, they're never important. We have no trailing zeros. We have 1, 2, 3 non-zero numbers, and then we have an additional 2 buried zeros. So this number is going to have a total of 5 significant figures. In this number here, we have a bunch of trailing zeros. There's no overbar, and there's no decimal point. So all of these trailing zeros are not important. Sometimes you'll see that done in this case, they've used a comma to help make this number easier to read, to group the number in sort of groups of 3. And a comma is not a decimal point, so that doesn't make those trailing zeros count. So this number here has only the 2 significant figures. Okay, so this number here, we've got 4 digits total, but 3 of them are non-zero numbers, and then we have this 1 trailing zero. It doesn't count because there's no decimal point and there's no overbar, so this number here has 3 significant figures. And our final example here, we have 2 non-zero numbers, so we've got at least 2 significant figures, and then we've got this 1 trailing zero. It counts because we've got our decimal point. So we have 1, 2, 3 significant figures. Okay. So, and here are a few examples where we've got overbars. All of these numbers here have trailing zeros in them. And what we're asked is how many significant figures are there, and additionally there's a second part of this question, what is the magnitude of the uncertainty? So what we need to keep in mind is there's no plus or minus notation indicated directly in here. So the uncertainty will be plus or minus 1 in the last significant figure. So we have a couple of things to work out here. What is the last significant figure and how many total significant figures are there? So we've got 1 buried zero, that will be significant. We've got 2 non-zero numbers, and then we've got a bunch of trailing zeros. There's no decimal point, there's no overbar, so these guys don't count. So we have 3 significant figures, and plus or minus, our last significant figure is this 5 here, which is in the thousandth position, so our uncertainty will be plus or minus 1,000. Okay, this is the same number, but it's written with the overbar over all 3 of the trailing zeros, which means that they all count, so every digit in this number counts as a significant figure. So we have 1, 2, 3, 4, 5, and 6. So 6 significant figures. Our last zero here in the 1 spot is our last significant figure, so this will have uncertainty plus or minus 1. Okay, so this one's a little bit different because we have just the overbar over 1 of our trailing zeros, which means that these last 2 here are not going to be significant. So in this case we have 1, 2, 3, 4 significant figures, and our last significant figure is in the 100th spot, so we're going to have 4 significant figures plus or minus 100. And finally, we have not an overbar present in our number, but we have a decimal point. And what that does is that makes all of our trailing zeros count. So it's similar, it's exactly the same as for number 5 here. All of our trailing zeros are going to count. So we have 1, 2, 3, 4, 5, 6 significant figures, and our uncertainty is out in this last zero here, so it will be plus or minus 1. Okay. So this is kind of putting a lot of ideas together. We're asked here to think about what was the smallest increment on the device, and what we know is that our guess will be 1 power of 10 or one factor smaller than the smallest increment on the device. So here we are, our last significant figure is in the 0.01, so that means the smallest increment on our device was in the 0.1. Here we have our last significant figure is in the 1, so that means that the smallest increment on our device was in the 10. In this case, our last significant figure that we've recorded is in the 0.1, therefore the smallest increment on our device was in the 1. In this number here, our last significant figure is in the 1, and so that means that the smallest increment on our device was in the 10. Okay, so that's really how we count up the number of significant figures. This is important because it tells us about the quality of the device used to make the measurement. And the rule of thumb is, the more significant figures you have, the smaller your uncertainty, the better the quality of your measuring device. Okay, so when we're adding up the number of significant figures, we know that all but one of those digits we read directly off the scale, and then we're just including one estimated digit that we're guessing at. Our rule for counting up the number of significant figures when we look at a measurement is that all non-zero numbers are significant, buried zeros are significant, leading zeros are never significant, and trailing zeros are significant if the number has a decimal point, or alternatively if the trailing zero is covered by an overbar.